Now that you have a general understanding of what a limit is, we're going to look at some techniques for computing limits, and we'll do that algebraically. And so we're going to start off with just a few basic limits, and these are almost obvious. The first is the limit of b as x approaches c is equal to b. And so this is actually the limit of a constant. And so if you think of the constant function f of x equals b, that's just going to be a horizontal line. And so no matter what c I choose, if c was here, as x approached c from either side, the y value is going to be b. If I chose another c, say this is c sub 1, and I let my x values approach c sub 1, my y value is going to be b. It's going to be b no matter what your c value is. So the limit of a constant as x approaches some value is always going to be that constant. The next basic limit is the limit of x as x approaches c. And so again we're going to think about what does f of x equals x look like. And that is a line that makes a 45-degree angle with the axes. And you can see that no matter what value you approach, say we approach 1, we let our x value approach 1, well our y value is also going to be 1, because the graph of f of x equals x is made up of coordinates 1, 1, 2, 2, 3, 3, etc. So whatever x value you're approaching, if we approach 2, the y value is also going to be 2. And so that's why the limit as x approaches c of x is going to be c. And the last one is the limit as x approaches c of x to the n is always going to be c to the n. So if we think of a power function, and say we'll just start off with something simple like f of x equals x squared, and we graph that. So if I let x approach 1, the y value is going to be 1. It's going to be 1 squared. If I let x approach 2, the y value is going to be 2 squared, or 4. So the limit of a power function, basically what you're going to do is just substitute c in for x. So the limit, if I said the limit as x approaches 2 of x squared, that's going to be 2 squared. Let's look at some limit properties that you're going to be using to evaluate limits when you don't have a calculator or when you don't have a graph in front of you. I'm going to just briefly talk about these, but we're starting off with two given limits, and if we've got b and c that are real numbers, and we have the limit of f of x as x approaches c is equal to L, and the limit of g of x as x approaches c is equal to k. So we've got two separate functions and their limits L and k. Basically, the first one is a scalar multiple, so if you have a constant times a function, you're allowed to take that constant and move it out in front. So that it would equal the constant times the limit. And since the limit as x approaches c of f of x is equal to L, then your answer is just going to be the constant times L. Number 2 on the list is the sum and difference property, and that basically states that if you have the limit of a sum, that's equal to the sum of the limits. And so in the end that would just be L plus or minus k. Number 3 is a product. We have the limit of a product is equal to the product of the limits. So if we have the limit of f times g, that's equal to the limit of f times the limit of g, and so that would just be the product of the corresponding limits L times k. Fourth is the quotient. If you have the limit of a quotient, so f over g, that is equal to the quotient of the limit. So we can take the limit separately, the limit of the numerator divided by the limit of the denominator, and that would just give us L over k, again providing that k is not equal to 0. The power, if I have the limit of a power, or some function raised to a power, that's the same thing as that limit raised to a power. 6, if we have the limit of a radical, that's the same thing as the radical of the limit. So you're allowed to move the limit inside underneath the radical. And this makes sense because a radical is just a power. You could rewrite this as 1 over n. And this works as long as this is defined. So if you have an even root and a negative L, that's not going to be defined. But if you have an even root and a positive or 0, then your limit will be defined. Right? And all of these statements up here are also true for one-sided limits if you're approaching from the left or from the right. So let's use these to evaluate a given limit. We've got p of x is equal to 4x squared plus 3, and we want to evaluate the limit of p of x as x approaches 2. So we're going to use the limit properties, and it really doesn't matter the order in which we use them in. We're going to start by using the fact that we have the limit of a sum. We're going to take that and rewrite it as the sum of two limits. So I've got the limit of 4x squared plus the limit of 3. Now I also have the limit of a constant times a function, and I'm allowed to bring that constant out. So it's 4 times the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 3. So now I have 4, it's going to be 4 times the limit of a power is just going to, so the limit as x approaches 2 of x squared is just going to be 2 squared using the power property, plus the limit of a constant, the limit of 3 as x approaches 2 is 3. And when I evaluate this, I get 4 times 4, which is 16, plus 3, which is 19. Now we did an awful lot of work there just using the properties of limits, but in the end, if you can see what happened, is that when you look at the original function and you look at the arithmetic that was involved to give us our answer, that's the equivalent of just evaluating the function. This right here is the same as p of 2. So we had p of x. P of 2 would just have been 4 times 2 squared plus 3, or just 19. So this brings us to another property, and that property is the limit of a polynomial. If p of x is a polynomial function and c is a real number, then the limit as x approaches c of p of x is equal to p of c. So basically when you're evaluating a polynomial, a limit of a polynomial, you just need to do what we call just direct substitution. You substitute the number in. Now since a rational function is just the quotient of two polynomial functions, we can use the same idea here. The limit of a rational function, p of x over q of x, as x approaches c, is going to be p of c over q of c. You just evaluate each function at the given value, c, as long as q of c is not equal to 0. In the next video, we're going to actually use some of these techniques to evaluate some rational functions and some polynomial functions.